Now we've already looked at the domain of relations. Now we're just going to be looking at the domain of functions, which is basically the same thing. Now we just have an m of x here on the left. Because we see a denominator, we know that x cannot equal 4, and therefore our domain will be all numbers but 4. Notice how I'm using the interval notation to say what values can be substituted into this function rather than those that can't. For this second function f, we know that t cannot be 0. Therefore, it'll be just the same as the problem above, except 0 will be our critical value in our solution. For this next value, we have to ask, when is this denominator equal to 0? Well, we know p squared will be positive, or 0, and then when you add 2, the smallest this denominator can be is 2. It is never going to be 0, and therefore our domain will be all real numbers from negative infinity to positive infinity. When we have a square root, we need to make sure that t minus 5 is greater than or equal to 0. That's how we handle square roots. Therefore, t must be greater than or equal to 5, and we would write the domain as 5 to infinity inclusive of the 5. In this next case, 1 minus 2x must be greater than or equal to 0. So negative 2x must be greater than or equal to negative 1. And whenever you are dividing both sides of an inequality by a negative, you change the direction of the inequality. So x must be less than or equal to 1/2. So the domain this time will be from negative infinity to 1/2 inclusive of the 1/2. Now for this next problem, we don't see any denominators, we don't see any square roots, and there's no logarithms, so right off the bat the domain is going to be all real numbers. And for this final problem, this one's a little bit tricky. Normally when we have a square root, we say x minus 5 must be greater than or equal to 0. But in this case, I'm only going to do greater than 0 because we can't have the equal to 0 because then the denominator would equal 0. So only x greater than 5 will be the domain. So you have to have or pay attention to two separate things here. Both the denominator cannot be 0 and what's inside the radical must be greater than or equal to 0, and that means only positive values will work. Notice that if you included the 5 on the left, 5 minus 5 would be 0, and you'd have the square root of 0, which puts a 0 in the denominator. So this is the domain we're looking for.